This is our first lesson, section 1.3, which is entitled Exact Linear Relationships. So the first thing we're going to do is going to go over here to the right-hand side in the notes, and we're going to talk about the main topic, the linear relationship. A group of ordered pairs, like those that we said last section, are said to be linearly related when a scatter diagram of the ordered pairs reveal points that lie on a straight, non-vertical line. And a model describes a real-world situation. So a linear model is a straight, non-vertical line that describes a real-life relationship that exists between two related quantities. Now, we're going to add to our names for independent and dependent variables. We're going to name the independent variables also as inputs, so values that can be input into a model are the values that are the independent variable can take on, and they lead to the output values of the model, and the output values are the values that the dependent variable can take on in a model. So from a linear model, we want to do one of two things. We want to make estimates or make predictions. The value of the dependent variable can be estimated based upon the values of the independent variable, and the values of the independent can be predicted based upon the values of the dependent. And that can be done by in the following way, which we're going to use an example to show in just a second. Estimating the dependent, what we do is we find the value of the independent on the independent axis, the x-axis, and then we follow the vertical line from the independent value up to the model. And then from the model, we follow a horizontal line to the dependent value, which is located on the dependent axis. If we want to predict, we're going to use this process backward. We're going to find the value of the dependent. We're going to follow a horizontal line from the dependent value to the model, and then from the model follow a vertical line down to the independent axis, the x-axis, and find that independent value. So let's go ahead and do an example. The example that we're going to do is on page 31 of your book, and we are going to be using the model right here that you see. So this is Leemann's section 1.3, and we're doing example or problem number 16. So I've written some stuff over here on my my notepad so you know what we're doing. So input and outputs, those are the things that we have kind of introduced: independent values, dependent values. So our first question, we want to know what the balance was 3 months after the student opened an account. If this linear model here describes the balance in dollars of a student's checking account at T months since the student opened the account. And so this is our T-axis, time, in other words, in months down here, and this is our dependent axis up here, are dollars, dollar amounts of the balance. So in order to answer the first question, we're going to be doing the estimation. So we're going to say, okay, 3 months after it opened, so here's our 3 months, and we're going to follow a straight vertical line up here to the model, and then from there we're going to go over horizontally to the y-axis over here, and that y-axis this time is called the b-axis because it's balance for in dollars. And it looks at what I can see right now is that we're at this line here. So this is 1,500 and this is 2,000, and there's 1, 2, 3, 4 lines in between here, so those must be increments of 100. So that would mean about $1,600. So I would write that in right here, $1,600 after 3 months. Now on the opposite side, after how many months would the balance be 500? So I would come here to the 500, follow a horizontal line over here to the model, and then a vertical line down, and see it would be approximately 5 months after the account was opened that the balance would be 500. Now this problem has parts C and D, and we're going to discuss those in a little bit later lesson in this section. So that's making predictions and estimating based upon a linear model.